Hi, good afternoon. Quick overview of Lesson 3 in Chapter 7, Similarity. So, two shapes are similar if they have the exact same angles, but they've been dilated. So, translations, rotations, and reflections, those all keep shapes that are congruent. Similar shapes are a little different. They're like the same exact shape, just made bigger or smaller. And that only happens with dilation. So how we check is we have to look at the sides. The best way to do it is to count the sides. Here, this side is 4, and this side is 3. And if I count up this side, 1, 2, 3, this side is 8, and this side is 6. I can tell that this shape has been dilated. So therefore, yes, they are similar. So, quick question for you. First, what does similar mean? Similar means they're the exact same shape with the same angles, but with a bigger or smaller size. Second, how do we test if they're similar? We have to test by making a ratio. I always do the new shape divided by the old shape, and I want to see if they're the same. So here, I would do 8 divided by 4. Well, that gives me the scale factor. This triangle is twice as big, or 2 times on each side. Then I do the bottom side here, 6 divided by 3. That's also 2. We are looking that these numbers match. When they match, we know they are similar. So let's go ahead and take a look at an example. Go ahead and either use your screen or use your own notebook to check the size of these two triangles. Are they similar? You should have found that these sides are 5 and 3 respectively, and these sides are 10 and 6. Therefore, yes, they are similar shapes. This one is twice as big as this one because 10 divided by 5 equals 2, and 6 divided by 3 also equals 2. All right, let's go ahead and check your understanding on this one. You want to check every flat side to see if it does correspond. See if it forms the same ratio. So go ahead and compare. First, find the sizes of AB and EF. AB is 3, EF is 2. Next, let's do AD and EH. AD is 5, and EH is 4. Now, these might look like similar shapes. They certainly seem like they're following a pattern. 2 is 1 less than 3, and 4 is 1 less than 5. But these are not similar. Well, why not? Because if I do a ratio, 2 divided by 3, here I'm just assuming EF is the new one. 2 divided by 3 is 2/3. 4 divided by 5 is the matching sides here. And notice that 4 divided by 5 is not equal to 2/3. The ratios do not match. Now, if the scale factor is smaller than 1, then it'll make the shape smaller. And if it's larger than 1, it'll make the shape larger. So why don't we try one final problem for understanding here today. So on your screen, you may need to zoom in a little bit or make it bigger. Are these two shapes similar? Why or why not? Okay. Well, you should have found that yes, they are similar. This is 3, this is 3, this is 6, and this is 6, which makes their ratios consistent. These are two similar triangles because even though the shape is bigger, the sides form an equal ratio. All right, thanks for watching.